Welcome to CoDe 1161, Design Computing. The big question that everyone is going to want to know is why we're here. For a lot of people, this is one of the CoDe mandatory courses, so I'm guessing you've just kind of showed up and you haven't looked at the course description. For those of you who have looked at it, then that's awesome. But we are here to learn some Python programming, which sounds a little bit like a sort of thing that you might learn in maths or something like that, but actually it's a much more interesting and rich set of things that you can do. And so we're going to try and cover that aspect of it rather than solely understanding how you can type some words and make a computer do some things. One of the big questions that everyone kind of starts off with an idea of is, what is programming? And you guys will hopefully have had a look at those questionnaire questions and written down what you kind of think it is. And so I'm going to go through what some of the things I think it is. And then at some point in the lab, when we all meet up, we're going to have a look at what you said and see what that kind of says. So the most obvious one is that it's just writing some words, writing code. So great, but you can write anything. It's not necessarily going to be understood by the computer. So as you're writing that kind of stuff, what does it mean? Are you writing the right thing? Are you writing something useful? It's like, that's the skill of doing it, is so you know that you're writing the right thing. You can just put any letters on the page, but it doesn't necessarily make it a good story, right? So another way of thinking about it is that it's like a recipe. So you are putting together a series of steps for someone else, or something else in this case, if you're doing a computer, to achieve some kind of goal, right? But recently we've been talking a lot more about like AI and machine learning and all those kinds of things. And so some part of that is that you're teaching a system how to behave rather than telling it exactly what to do. So that's great, but computers can often come up with alternative ways around problems. So if there's no obvious way to solve a problem, maybe it'll come up with a new solution, but it might not be the kind of solution that you're actually looking for. Then a lot of people also think about it in terms of it being a complicated process of specifying a problem to its nth degree and then describing that. So this is a classic NASA process diagram, and NASA very much like to make things work first time. You can't debug a space shuttle while it's already in the middle of a launch. And so they like to think through those problems very carefully. And I guess the kind of basic one that your general person in the street who you might talk to is just telling a computer what to do. So you're like, well, okay, do that, do that, do that. It's just kind of instructions. But one of the ones I quite like to think about it is as a form of philosophy. It's about being incredibly clear about your intentions. And so clear that an incredibly stupid device can execute your plan without anyone really having any kind of issues with what it's going to do. In the world, there's lots of things that computers do, and those computery things are all controlled by programming. And so some of those things are kind of invisible. So a UPS van is full of sensors, and it tells the UPS management if the van is reversing too much, or if it's going too fast, or where it's going, see if it's efficient, if it's driving kind of crazy. There's lots of uses in other unusual places, like tracking where cows go. You know, cows are an expensive thing. You want to know where it is. And things like this generative design bike. Now, I don't know if this is a good bike or not. I haven't ridden it, but it's definitely a different way of doing a bike. Then you've got other options like controlling robotics, and robots until very recently were doing some pretty stupid things. They could basically just walk around and fall over. But over the last few years, through different techniques of training them rather than being explicit about them, they've been able to do all kinds of stuff. And that's through systems like this, where they're trying to get systems to understand what they're doing. And this is leading into the driverless car stuff. So this is vision processing, but it's actually saying, well, what if it was snowy? Can I snowify this scene? And so you could use this in driverless cars, or you could use it in movies. So it's depending on which way you want to put it. Do you want to put the snow in, or do you want to take the snow out? You can use it for other creative situations where you can say, okay, take an outline and I want you to apply a style to it. And then you could use this one, which is kind of fun to play with, where you just draw a thing and it's like, oh, well, I'll try and figure out how this should look if I were to color it in. And so there's this great quote by C.P. Snow, and he basically said that it's okay to not know anything about sciencey things, but it's definitely not okay to not know anything about artsy things in a sort of polite society situation. And ideally, you guys are going to come out of this course with a kind of understanding of both. I'll just read you this quote. A good many times I have been present at gatherings of people who, by the standards of the traditional culture, are thought highly educated, and who have with considerable gusto been expressing their incredulity of scientists. Once or twice I have been provoked and have asked the company how many of them could describe the second law of thermodynamics. The response was cold. It was also negative. Yet I was asking something which is the scientific equivalent of, have you read a work of Shakespeare? And so that's like a pretty straightforward thing to say, but that leads you into a situation where people don't tend to be able to talk to each other. And ideally, at the end of this course, and at the end of the courses that you're doing right now, you'll have a good understanding of both sides of the world, so you can actually communicate between the two. You're going to be using that in situations like doing little bits and bobs in Grasshopper, or doing data analysis in a Pandas notebook. And you'll see it come up all the time in architecture. This is some analysis that we did a long time ago now about the implications of putting in a new footbridge, where that pink dotted line is. Like, do we put in a footbridge or not? And so this color change was showing the walking distance with the bridge and without the bridge. And so whole chunks of the city were changed, access to the city were changed by doing a simple thing like putting in a footbridge. And then you can also see this in terms of simulation and understanding society. This is the Schelling model using NetLogo that shows how racial segregation of neighborhoods comes up even if you have really quite tolerant people. They just want to move to be a little bit near us, people who are a little bit more like them. And you end up with sort of ghettoized neighborhoods with, not very many lines of code. It's a very straightforward understanding. You also get programming in buildings now. So these are the Amazon robots that drive the shelves around inside an Amazon warehouse, that take the shelves to the packers rather than the pickers going to the shelves. And so we're going to start thinking about buildings as computers, and having accessibility for computer entities inside the building, as well as it just being something as part of the design process. But there's always space for it in the design process. So this is the Kunsthal in Graz in Austria by Peter Cook. And this wouldn't have been possible in a kind of traditional doing things on paper world. But the most important thing that I think we're going to get out of this is that you're going to come up with new ways of using computers and using programming to achieve your ends. So whether that's to do different shapes, or whether it's to do a kind of building anthropology, or whether it's to do something that I can't even think about. That's the whole point of you. And you're going to go through this course and you're going to come out in the end and you're going to produce something new in the world. And that's going to be what's really interesting.